Hey there, it's Jeff again, and I'm back with a follow-up video to the project video we put together turning an inexpensive RC car into a robotic vehicle. At the end of that video, you might have been asking yourself, what should I do with it next? And that's what we're going to talk about now. If you take a look at the example code that we used near the end of the last video, it might look a little confusing if you've never worked in Python before or really any other programming language. So I thought it would make sense to talk through how that example code works and then talk a little bit about how you might modify it to do the things that you want to do with it. So let's start by taking a look at my screen here and walking through that short section of code that does the test movement of the car. It goes forward, it turns one way, then it turns the other. So the first couple of lines here on the screen, they're loading up some libraries, as we call it. So the first one is importing some libraries that will allow us to access the I/O pins on the Raspberry Pi. The next line here is importing a library for some time-based functions, so we can do things like pause for a certain amount of time. And this third line here sets the Raspberry Pi mode so that the numbering of the pins is sort of intuitive. There's other modes here that's really not something you need to worry about, but this is an important line for setting up the Pi so that our code will access the right pin resources. So just trust me for now, that needs to be there. The next four lines after this comment here, the grayed out line is a comment. The next few lines after that are setting up the 4 pins that we use to talk to the motor controller. So we're setting up pins 3, 5, 11, and 13 as output pins so we can turn them on and off and send signals to the motor controller to tell the motor controller what to do with the motors. We've got another comment on line 11, and then lines 12 through 15 are turning all of those pins, those I/O pins, off so the motors won't do anything when we first start up the car. We've got a variable here called move time, and we're setting it to 0.5. We're going to use that whenever we tell the car to move. It's going to do that move for half of a second. So we've got this placeholder, this variable called move time, set to 0.5. After that, we've got a few functions defined. Now again, if you haven't done much programming in the past, you might not have come across functions. Basically, whenever we want to do something, we can put together the commands that we want to do in a function and then call that function repeatedly later on. It makes our code cleaner so that instead of writing out, in this case, 5 lines that make the car go forward and then stop, every time we want to make the car go forward, we can define it as a function, and then whenever we want to make the car go forward, we just call go forward with 2 parentheses, and it'll do it. So it just makes the code a lot easier to read. We've got 4 functions defined here. We've got go forward, go back, go left, and go right. And each of them is a little bit different, but if you compare them to each other, you can sort of see what's going on here. So in the case of go forward, we've got pin 11 getting set to true, which is the same as setting it on or setting it high. And we've got pin 13 set to false. What that means is when you've got a pair of pins on the motor controller and you set one high and one low, the motor is going to turn in one direction. If you set them the opposite way, so that pin 11 was low and pin 13 was high, then the motor would spin in the other way, right? So we've got directional control as well as on and off. So in this case, to go forward, we set the motor in the back of the vehicle to roll forward. The front wheel steering is not doing anything. And then after we set those pins on, we've got the sleep command running for move time, which what we talked about before is set to half of a second. So it sets the pins high and then waits for half of a second. And then it goes and turns both pins off and it stops. Okay? So likewise, go back, just like we talked about it, setting pin 11 to be low or false or off, and pin 13 to be on. And so it's going to drive the motor in the opposite direction, make the car go backwards. It's going to wait for half a second and then turn both pins off. Go left is a little bit different. We're running the motor in the rear to make the car go in a direction, but then we're also moving the motor in the front to steer in one direction or another. In this case, it's going to make the car turn to the left. Go right does the same thing, but just like we talked about before, it's setting the pins for the steering motor the opposite way it did for the previous function, so it goes in the other direction. So that's all great. at the bottom of the example code, you can see that we've now used those functions that we defined. So we set up our initialization, we set up all our pins, we define our functions, and then at the bottom of the code, we actually use them. We tell it to go forward, and we tell it to go forward again, and then we tell it to go right, and then we tell it to go left. And then when we're all done with that, we run this last command, which cleans up our GPIO configuration on the board so that there's nothing left hanging out there, and then the pins are available for use next time we run the program. So we showed this in the last video, but let's try out this example code before we change anything, and just see how that looks. Okay, so we know that the car works, and we know that our test code functions, and that's a good place to start. But the test code right now isn't very interesting. It's not doing much. And we want to do something a little bit more challenging with it. So you may have noticed on the floor over there, I have an oval track taped out in masking tape. And you're going to want to do something similar to that for this next part. The idea is to make the car go around the track. And I'm going to be kind of picky about this. I want to make the car go all the way around the track and land back in the box where I started. And I don't want the car to go outside the lines at all. So I'm going to need to give the car a series of commands that are fairly precise. That's going to go all the way around that path and then stop right back where I started. We're probably going to need to modify the code a little bit to do that. I'm going to try first. I'm going to string together a few commands and see if I can get close. Why don't you pause the video and do the same? Okay? And the way this is going to work, if you take a look back at my screen here, is we're going to give it a series of these commands that we already have. We're going to call the functions go forward, go back, go right, go left, in any combination that we want to make the car go all the way around the track and land back at that starting place. So just as a guess, I think I'm probably going to need to go forward twice. I'm going to need to go right twice. I'm going to need to go forward twice again. I'm just copying and pasting lines here, but I could type them in just as easily. I don't think I'm going to go left at all. I think I'm going to go right again. I'll type it this time. Twice, like that. And I think that that's going to get me pretty close back to the starting point. I'm going to save this, and I'm going to try it out. Let's see what that looks like. And then depending on how close we get, we might have to make some changes to this code. But notice here, like for this first part, you don't really need to know anything about Python. You've got some examples, some commands, some code here that does something close to what you want. We're just going to modify it a little bit to tweak it and, and get it to do exactly what we want. Let's run this code and see how close we get to going around the track. Okay, so that wasn't bad, but it also wasn't perfect. And I mentioned before, we're going to try to be a little bit picky here, try to be exact. We want it to go around the inside of the line of the track, and we want it to stop right back in that box where we started. And in this case, we went a little wide of the line in one point, and then we ended up turning a little bit too early and not following the line all the way around. And I don't want to stop there. I don't think that's good enough. I think we could do better. So I can think of a couple of different ways that we could modify the code. Right? If we think about what it does, turning the motors on and off, waiting for a certain amount of time, I can think of some things that we could change that might give us more precise control about what that car is doing. I'm going to go and change the code to do one of them. I want you to think about it and see if you can come up with an idea on your own of what you could change that's going to get you to where you want to be. Let's pause the video here. We'll try to modify our code. We'll come back in a minute and we'll talk about what we did. And see how well it worked. All right, we'll be right back with you. Okay, let's look at my changes. Actually, let's do them together. If you take a look at my screen, I think the approach that I want to take is to change my functions, the go forward, go back, go left, go right functions, so that I can tell the code how long I want it to do each of those operations for when I'm doing it. So what I mean is, rather than using one of those functions and always having it do for half of a second, I want to say, go forward for 0.7 of a second, or turn right for 1.2 seconds. I want the ability to change that. This is how I'm going to do it. If we go to where we define those functions, right here, I'm going to tell Python that I want to provide another variable, sort of like move time up above right here, but we're going to use a different variable. And we're going to use that to pass in a number into the function that it's going to use. So I'm going to call it duration. I better spell it right though. Duration. And actually, while I'm thinking about it, I'm going to add it to all of these functions. And I'll show you how we're going to use this in just a minute. But I'm also going to modify the line in the middle of each function that says sleep for a certain amount of time. I'm going to sleep for duration, like that. Change the other ones. Oops, I'm not very good at spelling today. There we go. Okay, so now let's just go and talk about what that does in the simplest example of go forward. So now, when we call go forward, Python is going to expect us to also provide a number. And when it runs go forward, it's going to turn the pins on and off to make the car go forward. It's going to wait for whatever amount of time we provided when we called the function, and then it's going to turn the pins back off. So now, down the bottom of the code where I call go forward, I could say go forward for 0.5, which would be the same as we were doing before. But I could also say go forward for 0.6. Or if I want to go forward for, well, 0.5 plus 0.6 is 1.1, now I can just call go forward once, and I can say go forward for 1.1. So this is going to make it a lot simpler for me to do these different instructions to go around the track and change them and sort of tweak them. So through trial and error, figure out how long I need to go forward, how long I need to turn right in order to go around the track precisely. So let's give this a try now. I'm going to go forward, before I went forward for 1.0, I turned right for 1.0, I went forward again, and then I turned right. And I think we turned right a little bit early, so I'm going to bump this up a little bit. So basically I'm going forward a little bit longer, I'm turning right for a little bit longer, I'm going forward again for a little bit longer, and then turning right again. And we're going to see how close that gets us. Let's try that out. Okay, well that got us a lot closer. In fact, I'd say that we're pretty close now. A few more iterations there, modifying the numbers and tweaking when it turns and how long it goes through the straight sections for, and I think that we'll be able to follow that line all the way around the outside. Now there's still one last challenge after you get that sorted out, which is stopping in the box. You may have noticed that the car has a tendency to run a little while, even after the last command finishes. I'm not going to tell you how to solve that. I think if you think about it, you can probably come up with a couple of different ways to handle that. But I wouldn't call it 100% success unless you can land exactly in that box. I'm going to tweak my numbers, I'm going to change my commands a little bit, and I'll show you a clip right at the end here of me completing the challenge, just to show you that it can really be done. And I want you guys to keep working on this until you get it done as well. I'd love to hear about your experiences, posting in the comments. And you can also email me with the address that's in the video description. You can also contact us through social media. If you get stuck, you need any help, don't hesitate to ask. Don't hesitate to reach out. We're happy to answer questions for you. We'll talk to you real soon, and keep working on these.